Alright, so let's continue to talk about use substitution with two examples. So look at the first one. Integral x over square root of 1 minus x squared dx. Okay, so this is question 3a. Okay, so we have integral x over square root of 1 minus x squared dx. Since we're trying to do the use substitution, and it's very clear to see that if you take the derivative of 1 minus x squared, that's gonna give you negative 2x, right? And you can see that compared to the negative 2x and x, it's just a scalar multiplication difference. So starting from there, we set u equals 1 minus x squared, okay? And of course du dx gonna give us is minus 2x, okay? Like we talked about before, we would like to use the differentials to build the relationship between du and dx. So that gives us is du equals negative 2x times dx. Okay. So with this, we actually can start to do the substitution. First of all, you can see here, we have an x dx here, right? And we're trying to substitute this part in terms of du. And if you do a comparison, what we have here is du equals negative 2x dx. So what we can do here is right, if we divide negative 2 on both sides, we're going to have negative 1 over 2 du equals x dx, and this is exactly what we want, right? And of course the denominator here inside of the square root, which is 1 minus x squared, that's exactly our u. So with all of this, we're starting to make the substitution. Maybe we write it here. Okay, so x dx, so that's gonna give us, so let me write here. First of all, maybe let me write it into this way, so it's more clear. Okay, 1 over square root of 1 minus x squared, right? And then times x dx. Okay, so this is exactly the same thing. Why I'm doing this? Because x dx, we have it here, and 1 over this part we can substitute here. So after substitution, this is what we have. We have integral 1 over square root of u, right? And x dx, which is negative 1 over 2 du. So we can do negative 1 over 2, right? du. Okay. So negative 1 over 2 is a constant. We can take this negative 1 over 2 out. That gives us 1 over square root of u, also can be rewritten into u to the power of 1 over 2 du, right? And we can do one more, which is integral u to the power of negative 1 over 2 du, right? And up to here, things become very straightforward because for here, integral u to the power of negative 1 over 2 du, we can apply the power rule for integration to handle that. That's going to give us is negative 1 over 2, right? So it's u to the power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1, right? And then don't forget to plus the arbitrary constant c. And after simplification, you will notice that negative 1 over 2 plus 1 gives you is 1 over 2. You have negative 1 over 2 over 1 over 2, so that's going to give you is negative. This part is u to the power of 1 over 2 plus constant c. And like we just discussed in the first part, we need to substitute u back with 1 minus x squared. That gives us negative 1 minus x squared to the power of half plus constant c, and then we finish this problem. Okay, finish this 3a here. So this is very straightforward. Okay, so now let's look at back to look at problem B. So integral ln t over t dt here. Okay, and so let's see. So it's question 3, part B. So we have this integral ln t, right, over t dt. So for this problem, it's even simpler, right, compared to 3a. Why? Because look at what we have here. You know, ln of t and t. You know, if you set u equals t, you have du equals dt, and basically there's nothing you can simplify, right? Because if you set u equals t, you're still going to have an integral ln of u over u du, right? Nothing changed. However, if you set the u equals ln of t, so let's actually do that. Okay, so if you let u equals ln of t, and du for here is dt, right? Because u is a function of t, it's gonna give us is 1 over t, right? 1 over t. So du equals 1 over t on dt. Okay. So look at what we have here. We have 1 over t dt, right? So if we rewrite this into, right, 1 over t, right, times 1 over t dt. So now this is straightforward. So 1 over t dt, which is du, right? So, and u is ln t. So after this, let's do the substitution. Ln t is u, so integral u. 1 over t dt, which is du. So do you see, right? So integral u du, which gonna give us is u squared over 2, right? And then plus c. So after we complete, we need to substitute u back with ln of t, which gonna give us is ln of t squared over 2 plus c. And then we finish the last problem in this worksheet. And you know, you can always check your answers by taking the derivative for this part, right? That are going to give you is 2 times ln of t, and then times the derivative of ln of t over 2. So this part is going to be 0, and after all the simplification, you're going to get it here. Okay, so I'll stop here, and I'll see you in the next worksheet. Thank you.